Okay, so yesterday we did a binomial situation. Today we're going to talk about something similar but slightly different called the geometric distribution. Geometric. All right, so similar question from last lesson about Huntington Memorial Hospital. We're looking at, 5 babies. But this time, let's say, suppose we are not interested in the number of females born out of the next five, right? That was a binomial situation. But we're asking which birth would result in the first female being born. So we're just going to keep looking at babies until we find one that is born a girl. And we're going to stop once we find a girl. So the question is, how is this question different from the binomial distribution? What is essentially different about this question compared to our previous one? Go ahead, let me know. Unmute yourself if you think you know. What is different about this question compared to the question we had last time?
There's no set amount of trials.
Nicely done. Thank you, Billy. So yeah, there is no fixed number of trials, right? Before we were looking at exactly 5 and we just look at how many females there were. Here, we just keep looking until we find a female. It could be the first baby, it can be the millionth baby, right? We have no fixed number of trials. Okay, so the properties of geometric are very similar to yesterday's. We still are looking for 2 possible outcomes. We still want independent trials, and we still need a probability of success being constant. But that is it, right? We have no fixed number of trials anymore. So our acronym, instead of BINS, we're going to take the N out. So properties for geometric distribution, the acronym would just be BIS, B-I-S, okay? B-I-S. And once we have that variable, this variable, X, unlike our binomial, right, which was the number of successes, this X will represent the number of trials, right? Number of trials until the first success. Always the first. Always the first. Okay? So again, binomial yesterday, our variable was how many successes in those fixed number of tries. This time, geometric, it's number of tries to get that first success. All right, so that is a geometric situation. All right, so let's go ahead and, so possible values of X, all right, instead of starting at 0, it starts at 1, right? So you need 1 to get a success, or it could be the second, or the third, or fourth, or until infinity. All right, you can just keep on going. So those are the possible values of X. Okay, any questions about the properties before we go into an example? All right, then. Let me see. Nick, can you read this next example for us, please?
Yep. Suppose that 40% of students who drive to campus at your school or university carry jumper cables. Your car is a dead battery and you don't have jumper cables. So you decide to stop students as they're heading to the parking lot and ask them whether they have a pair of jumper cables.
All right, thank you. So we're going to let X be the number of students we need to stop before finding one with a pair of jumper cables. Okay, so the first question is this a geometric distribution? All right, so Kira, help me work through this with this one. Okay, so Kira, B, do we satisfy B, having binary outcomes? Do we only have 2 outcomes each try?
Yes.
Good. And what are the 2?
Whether a student does or doesn't have jumper cables?
Perfect. All right. The next one, I, independent trials. Is that safe to assume that we have independent trials here?
Yes.
Yes. And how can you explain maybe why? Maybe yes.
I don't. I think it's would it because like each student has their own car, so it's like. Wait, I'm a little.
Yeah.
I don't know if that one makes sense.
Yeah. No, I think it does. So essentially, like, if you have a pair of jumper cables in your car, is that going to affect whether or
No,
not
it's not going to affect
Harris
if
has a jumper cable in his car? Right? It doesn't really. So each car has its own thing going on. Okay. And then the last thing is S. Is the probability of success constant in this case?
Yes.
Yes. And what is that probability?
Whether or not. Oh, it'd be like 50%, right?
Oh, the problem.
Oh, wait, would it just be like whether or not they have it?
Yeah. So what's the probability of each person having a jumper cable or not? What does the problem state that probability to be?
Oh, 40%?
Yeah, that's it. All right. So that probability of getting somebody with a jumper cable is 40% every single car you're looking at. Perfect. All right. So this is yes. It meets all the criterias for, being a geometric distribution. Nice. Thank you, Kira. Okay, so now that we have that and P is 0.4, like Kira said, we want to find what is the probability that the third student stop is the first student to have the jumper cables. All right, so you stopped first car, no, second car, no, but the third car, yes. Okay, so this is a geometric situation because we're trying to find out when is that first success happening. All right, so switch over to your calculators. All right, and the same place we found binom is where we're going to find geomet. So go second, distribution, or vars, and scroll up, and geomet, PDF and CDF are right there for you. All right, so the PDF and CDF work exactly the same as with the binom. Since we want to find the probability that the third person exactly on the third, we're going to do PDF. And this time, notice we only have two things to input. The probability of success, which is 40% or 0.4, and the probability that that first success is on third one is 3 for the X value. All right, so this is what you want to write down on your notes. This is the work that you want to show. So this is 0.4, comma 3 in the Geomet PDF to give you an answer of 0.144. 0.144. All right, any questions on that? Anybody having any issues with their calculators? Let me know. In that case, let's go on to the next question, which is what is the probability that at most 3 students are stopped before finding one with the jumper cables? At most 3 students. So this is a little bit different than the first question, right? The first question says, what's the probability that the first success is on the third one? This question is asking, what's the probability that I find that first success on the third one or before, right? At most 3. So 3 or 2 or 1. So you can do Geomet PDF of 3 plus the PDF of 2 plus PDF of 1, or since we have CDF, we can use CDF. So Geomet CDF up to 3 will get me 0.784. All right. And that's the probability that at most 3 students are stopped before finding one with jumper cables. Okay, any questions on that? Okay, so well, this is the work in case, again, you want to see this is the work you can show in black on the quiz, okay? So here is the summary for Geomet. So if you want to screenshot this, feel free to screenshot this. All right, so we got P, same thing, probability of success. Q, same as with binom, right? And then X, this is different for geomet, number of trials until the first success. But again, PDF is when it's equal to, CDF is when it's less than or equal to. Here also is your mean formula. I used to have the standard deviation formula here, but it's rarely used. So I decided to take it out. So don't worry about the standard deviation, but for the mean for a geometric situation, it's just 1 over P. It's just 1 over P. All right, and that's your mean formula if you're asked to find the expected number, okay? All right, so let's practice. Okay, so go ahead and find that handout on Schoology. If you didn't print it out, you can print it out now, or you can just reference it on your computer.